All right, I think we're getting started. How's everybody doing? Good, very exciting. My name is Dan Kogan. I'm in product marketing here at Tableau, kind of look after Tableau plus all other stuff that we work with. Joined here by my good and much more interesting buddy from Europe, David Spezia.
Well, not originally from Europe, from Detroit, but I flew in from London. I've been based in London for 3.5 years for us. Been here for about 5.
It goes with the story, though. These caps and vests don't fly in Detroit. So today we are talking kind of best practice and strategy around Tableau with Hadoop. I always thought when people said Hadoop, that was the silliest thing, and it's pronounced Hadoop, until I did an event last week at a customer in Seattle with the gentleman from Cloudera who actually founded Hadoop and developed it and talked about how his son carried around this little stuffed elephant and called it Hadoop. I'm like, I've been saying this wrong my entire working career around this. Now, who is an idiot? Call it whatever you want to call it. In general, the principles we talk about, the things we talk about today, aren't just related to Hadoop or Hadoop. This can apply to most big data sets and scenarios in Tableau. So take that with an open mind. So what we'll talk about today is the overview of how Tableau approaches and handles big data and kind of our thinking in the space, the key to success in this area, and this kind of a non-one-size-fits-all strategy. It's a lot of expectation setting. It's a lot of just general getting your data strategy right and thinking about the back end before putting the front end Tableau on top of it, because that's where you can get a lot of the performance demons kind of out of the way. What some of those best practices are, and we'll talk through a few customer examples. And the good news is there are a ton of really good customer sessions on real-life use cases happening here at TC this week. Some have happened a little bit earlier today, but lots more. We'll talk about those at the very end and where you can go for more good stuff. So our general philosophy around this big data Hadoop world, it's being able to connect and access all of your data, no matter where it lives, whether it's in a relational engine, a non-relational engine, SQL, NoSQL, whatever. Finding your data wherever it lives, being able to access it is a core principle for us, and giving you your end users the best possible performance, so that sub couple second query response time that people are used to with Tableau extends those large data things. And we know that's been a pain point oftentimes around Hadoop projects. So real quickly, we'll just remind kind of the Tableau hybrid data architecture, because that's an important one here, right? So Tableau's got the ability to go directly against databases, and we have the ability to extract data into memory into our TDE engine. That database, the direct query model works really, really well for these fast, highly tuned analytical databases, your Teradata's, your Verticas, MPP data warehouses, things like that. Who here has hooked up Tableau to Hadoop using Hive? Who here has been happy with that experience? I saw one hand. That person's lying. So the live query engine makes sense in certain scenarios, and not with Hive. That's where you look at our in-memory engine as one option. That's probably the biggest default as people start to bring more and more in memory, but there's scale challenges in that. You're creating copies of your data. So there's got to be a better way to do this, and maybe a way to kind of balance these things. So that's what we'll talk about more today. I'll remind on our roadmap really quickly. It feels like it's really been within the last 18 months that I've seen Tableau projects starting to blow up over Hadoop use cases and data sets, but it's actually something we've been working on for a long time and building connections into. Kind of, I'd say the first SQL over Hadoop faster engine was Cloudera and Impala that we connected directly to back in 2013, and we've been iterating and improving on that connector for a significant amount of time, as well as that community's improved really, really quickly too. So Hortonworks coming out with LLAP more recently, Drill, Presto, all these different engines coming, tons and tons of innovation from the open source community. And one of our partners who ran a benchmark of Spark SQL, Impala, Hive LLAP, they did these over 6 months, and they saw 10x performance improvement just 6 months later in their benchmark testing. That's all open source community driven. So we've been in place with those connectors for a long time. We're continuing to add more and kind of stay on top of this, because it gets back that first principle of being where your data is and being able to connect to your data wherever it lives. But at the same time, it's not all of these databases are optimized for analytics use cases. So what David will talk about and we'll get into really helps you kind of manage that. So we'll do a really quick definition of big data. Honestly, no one has the wrong definition. I've talked to customers who were dealing with manual data entry on pieces of paper and then entering that in Excel, and now they moved into a SQL Server database, and it's still in the gigs, but to them that was big data, so that's fine. But for kind of purposes of today and for this talk, sort of the three variables we'll look at are the volume of the data. It's probably the simplest one. So traditional, maybe big data was moving into terabytes, but now we're getting into petabytes and exabytes and yottabytes and all sorts of other bytes. The variety of that data, that's another really important one. So it's not just structured rows and columns, but data coming in through JSON and Avro and Parquet and different types of file formats, streaming data, data from video feeds and sensors and all these kind of different things. So oftentimes that variety of data is actually what's driving that volume. Most of the new data getting created is non-relational data. And that's sort of what's fueled this big data movement. And then the velocity. So back to those sensors and devices and things that are creating data, generating petabytes and terabytes of data in real time. One use case I've seen is sensors inside of airplane engines. So Rolls-Royce built airplane engines, they put sensors in there. They're sending multiple terabytes of data across a transatlantic flight being generated off those types of things. So times that by all the different planes, Boeing, other plane manufacturers moving in that direction, makes a lot of sense, right? That data coming in very, very fast, huge volumes, huge variety. That's kind of what's driven this movement, this explosion. So exactly those types of modern data is what's driven the need for more modern databases. And the key here is really flexibility. With Hadoop, we learned this wasn't something in other NoSQL stores. This wasn't a faster, cheaper way to do data warehousing. I don't think that was anyone's intention going into it. It was a more scalable way and a lower cost way to be able to ingest large amounts of new types of data, and you need a more flexible way to do that. So, and I'll talk about that in a second. But for Tableau, we see ourselves kind of sitting at the middle of this intersection of the value you get from your new types of data combined with all the data you've had from your legacy repositories and applications. It's rarely a replaced scenario. So you've got new types of data where you've spun up new databases, but your SQL servers are still there, your Oracles are still there, tons and tons of Excel files are still there. And the beauty comes together when you can marry these things. That's where Tableau plays a role. I think there's a build here too. Tableau plays a role as that single interface and the way to get all that together. I think of one of our customers who's based out of Seattle. Hadoop was being driven primarily by their data science team. They were using it to track, this company builds web and mobile applications. So they were storing all of the user behavioral data through the application inside of Hadoop, and their data science team was running predictive algorithms on it, models to sort of understand what a user's next step would be. That's super, super valuable stuff to all the people in marketing and in sales and other areas trying to understand next logical purchase, churn, and analytics, all those kind of things, but they didn't have access to it. And they also had a lot of other data coming in from CRM and ERP applications going to SQL Server. So the value ultimately for the organization came when they were able to bring those two things together and now all of a sudden have a real 360-degree view of the customer. So that wasn't everything all of a sudden getting moved into Hadoop. All their existing applications stayed, Hadoop stayed, Tableau became that unifying stitching together of their architecture. So the key thing here when we think about the traditional, we'll call it kind of not old school, but the traditional database world and the data warehouse side and the data lake side of the fence, the biggest thing to take away from here to me is the agility piece of this and being able to land data in its raw format, not having to do complex ETL work, not having to get everything into rows and columns, land it in its raw state into that NoSQL store, and then being able to figure out kind of what you want to do with it a little bit later and get in those high-value use cases. Versus in those traditional models, it's much more fixed in what you can do and land there. But that brings us back to that initial equation of we've got this great flexible store. That's awesome. It's lower cost. We can run SQL over it, and so our BI applications can still talk to it. But how's the performance going on that? Is that what we expected? And that's where all those people that raised their hand around Hive were like, absolutely not. Minutes is probably a best case. We're probably in hours on some queries. And so this has been evolving over time, and different things in the community like Hive on Tez, Hive on Spark have been reducing those minutes into less minutes, some cases sub-minutes, but definitely less minutes. but the goal is still to get into that sub-second response time, especially in dashboarding use cases, right? And where there's repeatability and there's an expectation that your query is just going to load, and we're not stuck with slow conference Wi-Fi holding those things up. So I'll talk really quickly about a modern stack. This is what really put this up there to say there's a lot more in play here than just Tableau, ultimately in this whole conglomeration of items. We have all the different data coming in from different sources, your framework for collecting that data, where that lives inside of a data lake or a data hub, being able to aggregate that data, move that into different data warehouse or data marts built on different use cases, and then eventually Tableau kind of sits on the top of this pyramid. So there is a lot going on in order to deliver the performance expectations. It's different for each use case, and not necessarily all these things are in play. But the things we have to think about in order to be successful here, and they can't really be separated entirely, one is the data ingestion and preparation. How are you getting the data into the data lake? And then how are you moving it from landing zones into production zones, supporting those different use cases? The core itself, Hadoop is not a database. Hadoop is not one thing. I may keep mispronouncing this. It is a number of different technologies and projects that have come together to form this. So what's important is the right processing frameworks, the right storage frameworks. All of those different things will make an impact on that overall performance equation at the end of the day. And where we're going to spend most of our time in this talk is around that hot tier. Because what we care about is making the data fast and getting it to where you and your users really expect it. That's what gets David most excited. He is 2 seconds to query or he doesn't want to deal with it. So that's where we'll spend most of our time today. But really quickly, there are a number of companies, especially that are here at TC actually playing in the space, that I'd recommend having a talk with and understanding about how they help solve some of these problems. So in that data ingestion and preparation area that are really pushing down data onto the Hadoop platform for processing power, you have companies like Trifacta, Datamir, Paxata, Informatica, Alteryx, Cask, all kind of dealing with that data pipeline side of the equation. In the storage and processing in that general Hadoop layer, you have the three, I'll call them the three kind of big distros, which are Cloudera, MapR, and Hortonworks. Cloudera, I think, is the only one exhibiting here. You also have hosted, more PaaS type distros. Amazon has EMR. Also the ability to host MapR, Hortonworks, or Cloudera in their cloud. Same with Microsoft with Azure HD Insight. We actually have some Microsoft friends in the back of the room. They're handing out Surfaces to everybody here right now. So go mob them after this.
Surface Pros.
Surface Pros, yeah, 4. And then you have other companies also here that might be worth a talk to, like Treasure Data, that actually abstract most of that core. They're not built on top of Hadoop. They're built on Amazon S3 with technologies built in to do the data preparation, ingestion, and even query processing, kind of all in one bundle, so it's black boxed off. You trade off control in some things, but you get a much faster deployment time in those types of areas. So worth looking into there. And then the query acceleration, the exciting stuff we'll talk about today. Tableau Data Extract, Tableau Data Engine, that's one of the things probably most people default to. You saw Hyper this morning, so that's going to make that story that much better. But then you have companies, I kind of put his OLAP back, right? We've talked about this cube technology and moving away from that, but there's a much more flexible, much more dynamic way to do OLAP that's actually really catching on in popularity, specifically in the Hadoop space. And that's where we've seen a lot of customer success in this area. It's able to do that hot tier without actually having to move the data out of the database. So we have companies like Kivos and AtScale that are playing in that area. They're both here, so I'd recommend, and Jethro as well, that I'd recommend going and talking to them and learning about how they do that. So the big thing we want to kind of get across today, and this is where I'll hand things over to David in a second, is this paradigm of cold, warm, and hot data. So not everything needs to be in sub-second response time. Sometimes queries that run for a while are okay, especially in these cold use cases where a lot of it's being used for ETL is one case. Other times it's in predictive and machine learning algorithms where you don't need a sub-second response time. Those algorithms can run and then you'll get your models back and built. You have more exploratory use cases where it's people trying to answer unknown questions, right? We don't know what to feed into our dashboard. We are truly using Tableau to do ad hoc analysis. And that's where those warm cases are okay. And you can, Cloudera, Impala, Spark SQL, those kind of things are really helping to make those much more reality than Hive ever did. But the hot use case is the one where we'll really kind of get into and around how do we, for those more repeatable types of situations, how we deliver that, what some of the best practices are. So with that, I'm going to hand things over to David to take it away.
All right, cheers. Thank you so much, Dan. Really appreciate that. Thanks for setting up the stage for us very well. And we're going to talk a little bit about our cold, warm, hot strategy. That's just kind of what we call it. You know, you could also refer to it as raw, entity, and analytical structures. If you don't want to have the cold, warm, hot nomenclature, that's also fair play in this space. And what we see is the larger the data volumes are, the more likely you are to have that raw, semi-prepared JSON kind of CSV type data structures. And that's where Hadoop comes into play, and it comes into play quite nicely, and we can store lots of data very, very cheaply and analyze it later, right? When I travel around all of Europe with Tableau to go to conferences and events, I actually carry 1.5 terabytes of storage just on my person. And 15 years ago, that was almost an unfathomable amount of storage. So storage is cheap, and we're storing anything and everything we can get our hands on because we know there's value there, we know there's a story. A lot of data that we're used to in this space is those relational data warehouses, those relational databases. That's what I grew up on. That's what I cut my teeth on with Kimball stars and cross-tabular reporting all back about 17 years ago, right? So we're very comfortable in this area, and that's preparing transactions into semi-analytical structures to do enterprise production level reporting. Then steps in your analytical databases, your analytical warehouses. These came in to take some of that burden off of those traditional data warehouses to speed things up for read-style queries. Can we go with a column store architecture? Can we have an MPP-style execution to make our data warehouses and our speed to business insight and business intelligence that much faster? And we saw loads of tools come into the market that generated loads and loads of SQL queries. It's kind of spurring some of that back-end development. And we also see Tableau data extracts as a great way to look at a decent amount of data to speed things up for an analytical purpose, right? We have a column store architecture, we're in memory, and we can actually do some pretty cool things, and I will show a demo later on some of the bleeding edges of what we can do with extracts. But what we're seeing a lot in the marketplace is the technology creep from Hadoop. They're always going after new libraries. The pace of innovation within the Apache Foundation is mind-boggling in this area because there's so much of a business opportunity and there's so much value to be exposed to BI tools and business end users that are investing into Hadoop. And you can also see Tableau making an investment as well with our Hyper engine as well. We want to be able to put more data into Tableau and start federating some things as well, just to make it easy, or to make it Tableau easy. Anything you want to add there, Dan?
No, I mean, I think our general goal with Hyper, it's not necessarily to take more data and put it in there, but it's to meet that use case that you guys have given us time and time again. We need to be able to load data faster, we need to be able to store more of it. And so that's where it's coming into play.
Excellent. And so our cold use case normally is a Hadoop Hive style use case. We're going to have data exploration done there. We're going to have people wearing a mining hat going in there, writing code, using Python, Scala, Java, right? These are a different breed of individual, the modern data scientist. They're going to do ad hoc report modeling. They're going to model some concepts. Hey, is this idea even worth exploring, right? So they're going to go in there and they're going to be the kind of the spearhead. And they're going to explore concepts that they will migrate forward to analytically optimized structures. So maybe we move it into some kind of aggregated table and expose that out to the BI solution, or maybe we move it forward in the stack and move it up to an Impala or something else. And we see, the core technologies for us, the three major distributions of Cloudera, Hortonworks, MapR, and we also see people using Amazon EMR, and other areas to do these types of use cases. And after we get those use cases moved forward, here's some stuff I've actually seen out in the field. I've been working for Tableau for 5 years. I get involved with a lot of our big data projects in Europe. It's really quite fun. I'm seeing people taking those fixed width financial transactions, and they're just storing that raw text so they can do analysis on top of that. Same thing with airline booking records. You get those airline booking records. They definitely look like an old green screen style printout, right? People are storing just the raw text output. Same thing with e-commerce. E-commerce is huge in the big data space. They might be the biggest generators of this data that I've seen. E-commerce and the massively multiplayer online games are really the biggest two things that I see when I'm out in the field. They have dumb amounts of data sometimes. It's mind-boggling, right? Because we have all your browsing activity, all your click activity, everything you've done. It can be a little scary sometimes. People like to do A/B testing, campaign optimization. I think you yourselves as consumers in the web, using your Facebook app and other things, you've seen a lot more targeted ads towards your interests. We're really good at that as marketeers, almost creepily good, right? And the same thing, so besides the video game industry and e-commerce, I also see quite a lot of big data use cases in telco, because there's so many different devices that have to be in place in the infrastructure to move communications forward, right? So every single vendor of even the hardware makes a big data kind of play, and they make a big data application. And then the people that optimize networks, people that own the networks, and then finally the people that you pay money to in the long run, like your Vodafones and AT&Ts and Verizons and Sprints of the world. And there's products all through that entire stack, right? We do some interesting stuff with security, right? We kind of know where just about everybody is, right? And if you ever saw our Where's Will demo from Mac Bryla, he got pretty creepy with what he was able to figure out. And we also have all your HTTP traffic off this device to a tower and back. So we can probably tell who you are, as your browsing history would suggest, right? So it's pretty interesting what we can store. And a lot of us are used to this warm use case, this entity level analytics, objects that were being created and kind of reported on over time. SQL Server, Oracle, MySQL, Postgres, Impala, Teradata. These technologies are not going away. These technologies will continue to be around for a long time. And you do see, Microsoft investing quite a bit in their data warehousing with their column store architecture and things, and Oracle with their Exadata appliance, and IBM with Netezza and then DB2 Blue and all these others. So this is a very mature space, and a lot of people are moving towards the next part of the space, and this hot structures, these analytical databases that we see, column store architectures designed for massively kind of parallel processing environments where a lot of read queries can come into those engines and really give an entire enterprise data back to tools, right? Tools like Tableau and a few others create this massive data vacuum in a lot of our customers. So you've got more people with access to data through tools like Tableau driving a lot of investment in this area as well. Most common use cases here are like the BI application style use cases. I'm making a dashboard of KPIs for people to consume on a regular basis, or I just want to really speed up my analytical queries at large volumes of data so I can drag and drop and answer questions very, very quickly. We see technologies here. We invest ourselves in this space with our Tableau data extracts. We see lots of HP Vertica out there in the field. Exasol is here. They're based out of Germany. I see them a lot in EMEA, more than you would see them here. Of course, Pivotal, Greenplum, AtScale, and Jethro.
Yeah, Kairos as well, who've seen a lot more recently. So this is a fun space too. There's just a lot of people. While the warm layer is very, very mature, the hot layer, tons and tons of innovation coming in here.
Yeah, it's exciting. Every day we almost run into a new vendor. We're talking to somebody new. You're always sending emails. Hey, you
check out these guys. Yeah, exactly.
Check out these guys. And we just go geek out on data for a while. So I will say Tableau data extracts do play in this space as well. The amount of data we can push into them, the biggest one that I've ever seen was about 264 gigabytes and 4.1 billion records. And I'll get to show you that later because I created it. And you can use extracts, right? If you're exploring a concept in Hive and you very quickly want to get a dashboard or some visualizations out to an end user, why can't you just grab the top 10% of that data, whip together a quick dashboard, persist it into a Tableau extract, and then send it on to somebody so you can be agile in that analytical process. They can help you make changes, you can drag, drop, make new charts and visualizations to answer new questions. You could also holistically extract when you have smaller data set sizes, less than a few hundred million, less than about 100 columns. Or if you just want something to be portable, right? I very often am on planes flying somewhere. It was 11 hours to get to Austin from Heathrow. And so I brought a data set with me that actually one of our guys in Seattle gave me. He's got his own private MechWarrior server for BattleTech, and he sent me all of his game logs for the last 15 years because I'm going to a gaming conference in Tel Aviv next week. And so I'm analyzing that data on the fly.
And that is Tableau sales consultants, just in a nutshell right there. Thank you.
I am a professional geek. And of course, you can have a live connection when you have tuned your back end, right? When you've tuned things in like Impala plus RK or using the Spark execution engine, you're using additional layers like Kivos, and you're using additional layers like AtScale, et cetera. You can use that live connection to have interactive queries on multi-billion row record sets. And they put acceleration layers even behind that yet to build microcubes, to build kind of caching layers in HBase, et cetera. All right, so as you're using Tableau extracts, right, you can sample from them. You can pull a top n number of records. You can do filtering, just I need the last few days and the last 90 days, right? So that's something to also keep in mind when you're extracting that data out of those source systems. So general techniques for improvement within the Hadoop space. We do recommend you partition correctly, right? A partitioning strategy, an indexing strategy really makes a big difference at some of our use cases. I've seen 7 billion row tables be 20 times faster for analysis when we built the correct hierarchical partitions. And that's all we changed. It was the same data, we just changed the partitioning. The new file formats that are always coming out, your column store file formats as they mature, those are things we really like. You can use initial SQL and custom SQL in Tableau to give execution plans and things to your engine to allow it to fire the way you want to as a big data engineer. So if you want to go explore some of the kind of more niche use cases or explore some of the ways you can really push your clusters, look into initial SQL and custom SQL because you can do a lot of customization on the way Tableau is writing those queries, right? Things we love, right? A big flat single denormalized table in a column store architecture. That's one of the things we love the most. It makes it really easy for us to do that analytical query. And then obviously monitor your Hadoop clusters for long running queries and the faster execution engines. Let's invest in those. Let's take a look at those. Let's quickly stand those up and see the new projects that you're seeing in the Apache Foundation. Are they helping you improve the query performance? Because all the big data engineers I know always love playing with the newest tools, and they will do it even on their own time. I'm guilty myself. So certain pitfalls that you should be avoiding. Tableau allows you a lot of functionality as an end user, and sometimes you can drag and drop and do something unintended, right? So things with data blending on large cardinality data sets, right? So email addresses, weblog IDs, things like that. If you try to do a data blend on that, Tableau is going to perform really poorly because we're going to try to do some things to make that data blend actually happen, right? And so avoid also unnecessary joins. The more we get closer to column store type databases, what we see is joins are a little less performant than one big flat table. Like even things like HANA could be considered a big data store for us, and we like a big flat object more than tables joined together, right? And connections with huge numbers of schemas and columns. So Tableau sends out a lot of exploratory metadata style queries to bring back information to the end users in the interface. If you've got a whole bunch of stuff in a database, a whole bunch of garbage, or just really a lot of complexity, so you make one database and throw everything in it, Tableau is going to write some fairly expensive queries to pull that stuff back out. So we always like simplicity. All right, so you want to leverage your multi-tiered approach on your data. And you can do that quite easily in Tableau. And I'm going to kind of move forward on this one and talk about the human scale of data, then apply it to Tableau. So I think all data has a hierarchy of some kind. You can start up in the clouds and go all the way down to the raw data in the weeds. And most of those can be things like a time hierarchy. Almost every data set I've seen, especially a big data set inside of a Hadoop store, it's got a timestamp of some kind. And we can look at years, we can look at the individual months, we can look at weeks, and then we can look at days, and then we can actually look at the raw transactions. And if that doesn't have a time-based hierarchy, you can also have a geographic hierarchy. You could have a personnel hierarchy. Or if you don't really have a hierarchy, I go look for the lowest cardinality dimension, add that on, because that's probably the top of some kind of pyramid, right? And I start going down from there. And as we do that, we can navigate that pyramid and drill down to the context. And each one of these tiers could be a different aggregated object. It could be in a different database execution layer. It could be in a different database itself. And so I can grab a year and then move down. I can grab a month and move down. I can grab, ooh, there's some interesting transactions happening on this week, move down. Ooh, now I need to grab the actual raw transactions from a cell phone tower and throw that back. Ooh, that wasn't the right tower. Let me move back up and look at a couple of different weeks. And then we look at a different region. We look at yet another region and drill across that. So navigating large data sets with this top-down approach and using things like actions to jump between tiers of data is an incredibly important approach when you're working with billions and billions of records. So think of the analytical flow and build back-end data structures to match that analytical flow. So we use action filters quite heavily at Tableau to produce guided analytics. And guided analytics is very important because I can have a very high performant analytical query at a high level of aggregation. I can jump down to grab more context from a warm or row level type store. And then I can jump further from that into the cold store and say, ooh, I just want the documents for this period. And Tableau allows us in one ubiquitous interface to query Hive, to query Impala, to query at scale, and to query the data engine. And we can put all 4 different technologies in one view. Whoops. We can put 4 different technologies in one view, or we can jump from view to view to view, or we can even jump from workbook to workbook to workbook. And being able to leverage this is going to be one of the more important things you take away from this class. So let's give you something more tangible than me just telling you to do this. And so there's got to be a few baseball fans in here, right? Yeah, there's got to be. So I'm going to go ahead and open up a workbook that is going to be sourced from 4 different systems. And I'm doing it live over the wire, and we tested it earlier, and everything worked out okay. So hopefully this thing works out. The fact that it's just sitting there staring at me is making me very nervous.
I know. He said earlier, though, he's like, we could have done this off an extract day. He's like, these people paid money to come to Tableau conference, came here to Austin. They're getting a live demo. Or they're not.
And see, it's just sitting here spinning now.
And his 15-year-old Dell machine says, no, they're not.
It's a Deathly Hallows machine. All right, so it's just going to sit there, which makes me nervous. So let's switch over to the backup one. Oh, and it's going to leave the splash screen there. Yay! Let's just do that. Because it's a demo, it's going to fail, I guess. All right, we'll try this one more time.
This is desktop organization best practices.
There. See, now I cleaned it up.
That session today.
All right, this is making me nervous that it's sitting there doing that. It looks like I have just going to be crashing, I guess. All right, so I'll show you the portable one. That one should open unless I'm just having a licensing check issue. I did open this earlier. Oh well, let's go to this then. All right, so the backup then. I'll just let that run in and of itself and try to play with it later. I'm going to tell you a different story now. I'm going to switch gears completely. I was working with a customer that gave me 3 terabytes of CSV files. I had about 7 billion transactions in those 3 terabytes of CSV files, and they said, we're going to invest in a big data analytics platform, but we want you to prove it first. And I said, well, I know a guy who can write some Python, and I've got me a library to spit out Tableau data extracts, so I just scaled up a machine to spit out a bunch of Tableau extracts. So I spit out 12 different extracts that I pared down to 6, which I pared down to 2, which I ended up creating one big extract. So this is a 264 gigabyte Tableau data extract. I believe it's the biggest one that's ever been created. I haven't been told otherwise. I've asked a few different people. And that's a big raw store. I've also got a 2.6 gigabyte store that is a aggregated pared down version of that. So I've got a hot store and a cold store, both in the data engine here. And I'm gonna go ahead and open Tableau workbook, and hopefully this workbook, it opens. So I'm gonna have to blame the local machine, or it's an ID10T error, I'm not sure. So who flies the most? Well, it's the richest country in the world, it's Americans, followed by the Germans, and then the Indians. There's a large number of people down there, 1.3 billion, then the French, Spain, Italians. And where are the Germans flying to? Well, mostly other places within Germany, and then the United States, Spain, etc. But I just want to show you some other thing real quick. This data set here, right? It is 4.1 billion records over quite a few different dates. And these are the number of records over different dates, about 100 million or so transactions a month. And the spike in my transactions here is March 2015. I can select March 2015, so I can grab a context, and now I can see all of the places people started flying from in March 2015 in aggregate. So we should probably look for Austin, Texas. That would make sense considering where we're standing right now. So I can grab Austin, Texas, and I can see there's Bergstrom Airport there, had about 85,000 passenger flights in that month, and now I can select that, and I've jumped tiers there, right? All I've done, I went from that aggregate 2.6 gigabyte extract to the 264 gigabyte extract, and now I can see all the destination countries from Austin. Not surprisingly, most flights went to the US, and then Germany, India, Spain, etc. And then this flight just really recently started, the flight to and from Great Britain here for the flight to Heathrow. And now I'm looking at the city that I've flown into from Great Britain for that month, originating from Austin Bergstrom Airport. And this query here is going to take about 45, 50 seconds. So I can drill through just like that from any data source to any data source. Now I'm going to go check on the local demo. Yay! It came back. I'm excited about that. Let's see if I have both of them or just one of them. All right, this is the one I really want to show. Okay, so that's the Tableau data engine at very large scale of records. It was lots of fun to build that. It was lots of fun to see what the data engine is truly capable of, and it's capable of some really, really kind of fun stuff. So now I'm going to switch gears a little bit and talk about this batters demo. And everyone can understand a hierarchy of baseball. We've got teams have players play for seasons, and those seasons can be for many different teams, right? There's some really good object relationships there. And I've got an Excel file here I downloaded from the internet that has teams and their stadium latitude, longitudes that I just ripped from a Google Fusion table. I've got a Cloudera Hadoop Impala cluster that's running on the Tableau infrastructure in Seattle. So this is running in Seattle. It's a Cloudera Hadoop Impala cluster. I've also got a SQL Server data warehouse that's running in my data center in London. So I've got this SQL Server data warehouse as my London sandbox SQL Server data warehouse. And then finally, I've got a local Tableau extract here. So I've got a Tableau data extract that's running just off of the hardware here on this machine. And what I can do is on one dashboard, I can just drill through. So I can go ahead and select a really good team like the Detroit Tigers. And then after the Detroit Tigers, I can leave some breadcrumbs there for people that may not be used to guided analytics. I can go ahead and select a player like Lance Parrish, who played for many different teams across many, many different seasons. And here I can see he spent some time in the NL, some time in the AL. It's got a pretty wide variance of seasons here with home runs and batting average. And I can see he played for the Tigers, the Phillies, the Mariners, the Indians, the Pirates, and the Jays. So it's really cool to see Tableau just jumping. What I'll do now very quickly is I'll turn on Tableau's performance recorder just to show you us speaking all these different syntaxes. I'm going to switch over now to an extract dashboard. So this is a dashboard created 100% off that extract. And I've set up some actions deliberately to run locally first. So now if I grab a team like the Sox, I think the Sox are this one here. So if I grab the Boston Red Sox, it highlights locally. And now I can hover over this mark, and it kind of gives me a little tilt that I'm going to drill down for the Boston Red Sox. And now I'm going to jump to that SQL Server data warehouse. And I've got all my Boston Red Sox. This little outlier here, that's Manny Ramirez. He's the only professional baseball player I know of that actually urinated on the field of play during play behind the Green Monster. So when I'm telling people in Europe about baseball, they usually don't care, but then they go Google Manny Ramirez because of this story. And now I can kind of drill down for Manny Ramirez. And he actually started his career with the Cleveland Indians, then moved over to the Red Sox, and then obviously went from there on. And so what I'll show you now is kind of what Tableau was doing in the background. I'll go ahead and stop this performance recording, and I'll get back a Tableau workbook that'll tell me what Tableau was doing. So this is a little bit more for the geeks in the room, for the business users in the room. Close your eyes, I will be showing code. All right, so I'm gonna switch this to 0 seconds. Whoops, switch that to 0 seconds. And I'll go ahead and keep only the executing query commands. And now, as I scroll down a little bit, I can see right here when the Impala SQL was written, it says where player equals Manny Ramirez, right? So it's passing that down to my next data level. And if I pick one of these smaller running queries, right, this on the where clause, if I were to kind of sum down in here a little bit, you would see the team being placed into that query. And then finally, maybe one of these SQL queries will have it. It's too much of a clause on there. And now if I scroll down a little bit further, some of these were actually cache hits on my Tableau data engine. So we speak to all those different syntaxes at the same time. And it's really easy to set up in Tableau. As I'm looking at this extract dashboard and I'm going down with the actions, this drill down action here was set up right from that one sheet to execute down to the next dashboard. And right here, I'm setting a team to an Excel file and to the SQL Server data warehouse all in one action, right? So you can get compound in the way you do these actions. And this is a strategy, once you have the data in the right architectures and you have the analytic flow that you want, you can use these action filters to just navigate that pyramid and give people a really fast, performant dashboard, allowing them to just look at so many different facets of their business as they drill into it to their relevant contexts that they'll be incredibly happy with the performance of Tableau on top of their 3-tier data strategy. All right. So switch back over to PowerPoint. So I want to tell you a little bit about some places we've been successful with these 3-tier strategies. We've been very successful with a company called Wargaming. They make a game called World of Tanks, World of Warships, World of Warplanes, an MMO out of Belarus and Cyprus. King.com, bought by Activision. They were the makers of a game you will all know, and we'll get there. And then GoPro, of course, they make cameras for today's YOLO adventure-obsessed youth. So Wargaming, their use case is they wanted to move from a legacy system of Excel and ticket delivery. You literally had to get a ticket and go to a desk, and then someone would give you an Excel file on a USB, right? I'm surprised it wasn't on a 144 floppy. So they wanted to modernize, and they brought in a guy by the name of Craig Fryer, who actually works for Tableau now. If you want to have more of his story on this, I would highly recommend you go talk to him. And they wanted to look at game health, business health, and market health. So are the games working? Are they up? Are we making money from the games we do have up? And what else is coming into the market that could compete with us, right? And so what they did was they brought in an architecture to be flexible and agile so they could actively change the way they look at these 3 different business areas. So they brought in Tableau. Tableau was like the #1 choice they wanted to bring in for analyst and self-service. They brought in another layer called at scale to have business-friendly data. You can do these virtual cube definitions that business users are kind of used to seeing because it feels more like a Kimball star type definition. And then they had Cloudera Impala for their raw document storage of log ingestion. They had over 8,000 game servers with very active user communities. And what did we learn from this? Well, Tableau with this acceleration layer, these at-scale cubes on Hadoop, are effective for providing self-service concepts at large scale. These cubes were able to store business logics, hierarchies, and measures, the concepts business users are used to. These logical cube structures did not force us to do data processing. We didn't have to persist the data into those layers, and when we wanted more data, we just wrote Impala SQL. This Cloudera, for us, is a leader with a 30% plus market share in these inside of the Hadoop world for data warehousing, and users can both fish and persist, right? We can go look at some logs, find some cool stuff, persist it forward up the structure for analysts to use, and right, technology partners for us can change the game with big data analytics. For us, it's not going to be all just Tableau that handles your big data use cases. It's more of a partner play for us with the different technology vendors.
Yeah, and as we said earlier, the good news is we're now getting almost spoiled for choice in these really good kind of flexible cube technologies for Hadoop, so kind of drill into those a little more, but it's not always the same limitations we always kind of think of with SSAS.
Very good. Another company, King.com, they have 1.5 billion game plays per day with 149 million daily active users. That's a large user community. I wish we had that many people on Tableau Online. I could probably retire, right? They generate a petabyte of data per year and over 25, it should be the next one up from petabyte of data per year, 25 billion events per day. So every screen click is an event for them pretty much, and they log all of that back. They want to understand how, when, and why players make in-game purchases, right? Because they're going to sell you like a candy rock hammer for a quarter or something, right? And they want to understand when you get stuck, how they can sell that to you. And they really needed to overcome the limitations of Hadoop as an open source solution for data management and analytics, right? Because they have a silly amount of data. And so their high level architecture was to take game data from the server logs, they push it into Cloudera Hadoop, then they use at scale with their data scientists, and they actually use Exasol as well. They have a very large Exasol cluster that they use with Tableau Desktop with their business analysts. And so what do we learn from all this? Well, we learned that 64-node Exasol clusters are crushingly fast for analytical query. Exasol, a rapid-fire analytics database from Germany, they love Tableau. We have a very, very strong partnership over there in EMEA. They even have a small product line called Tableau Turbo that you can buy, appliances like, I think starting at 500 megabytes, 500 gigabytes, a terabyte, 2 terabytes to get started. Like for like on billions of rows, we wanted to prove like for like query. We had an average of about 13 seconds with at scale, and when we had those same things in Exasol, we had about a 5-second query average during the testing that we did. And we saw some pretty serious business benefits with this use case. The self-optimizing analytical databases, right, helped them keep the focus on the gaming experience as opposed to worrying about taking their engineers and putting them on analytics. Queries that used to take hours for them now take seconds. That's a big change for them. Business insights are available at the right time when they want to make decisions. And this flexible solution, so the agility in this solution, gave them they can rapidly respond to the business's changing needs. So GoPro is another use case of ours. They created a data science and engineering team inside of their product organization. So they stood up a brand new team. And they used the Cloudera Data Lake platform, and they called it TPS, the Philosopher's Stone. So they actually create TPS reports. And they combine data from email campaigns and Google Analytics with CSV and JSON. And so their high-level architecture is they use exact target, a component of Salesforce. They use Google Analytics. They push that through Trifacta, and then they use Control-M for scheduling some of those ETL jobs, push it into Cloudera, and then use Tableau Desktop to do analytics. So we learned some lessons there. Tableau democratizes the analysis of data, and for them, Trifacta democratized the data wrangling, right? So allowing people to wrangle with that data and to create new structures for analysis.
And these guys are actually here this week presenting too. So I think you'll be able to hear it from the horse's mouth pretty soon.
And we used the Impala with our Parquet structures for exploratory data sources in Tableau, and we saw great performance. We used extracts for the production workbooks after we pulled it forward. And that combination of Hadoop, Trifacta, and Tableau gives agility and just reduces the overall time to insight and the overall cost to insight for your business users. All right, so we're right on time. Look at that. Look at that. Amazing. Wow. Wow, on the summary slide now. Oh no, there's a whiteboard. I misspoke. Dan, I misspoke.
Well, now you gotta go 30 seconds. Keep us on time.
Okay, so we're gonna talk about users, like miners, and our analysts, and our web consumers. Right, miners are comfortable writing code, so we're trying to put this whole big picture all together. And those miners are also comfortable writing ETL-style code and things like statistics. We can then push the things we learn from writing that code and analyzing the data into structured objects. Those structured objects can go through Tableau Desktop. People can create workbooks, they can create data sources, find moments of insight, take that insight, push it forward to our server, and then share that with web users over the browser, and people can use web authoring to interact with those structures that they created.
For our friends from Microsoft, they can also use Internet Explorer, I think, too, right? It's not just Chrome.
I don't know what that logo is. I totally draw that by hand. So we look at the cold, we look at the warm, we look at the hot. And this is like, when I start conversations with companies, I'll typically draw this 3-tier Venn diagram and talk about this, and then explode from there to wherever they want to go. And as we find concepts with our miners, we can move them forward. And as we find concepts with our analysts, we can move them forward so it's fast for the executive. And the executive or the end user can interact. We can then refine, and then we can question, right? We can go jump through those places of the cold, warm, hot structure. And that makes the golden triangle of Tableau happiness. We can store any type of document that we want. As we store those documents, we can use a query interface and execution engine. We can store things into data warehouses or object type structures. We can use analytical structures and MPPs to speed things up, and finally use data engine queries to push things forward. So if you wanted one picture of how the big data universe fits in top of Tableau as a platform, this is kind of that picture, and this is what this is trying to be. It's way more effective on an actual whiteboard, but I had fun making this. All right, so for some lessons learned, Dan, you want to do this?
Yeah, I mean, one thing just to take away is you can use Tableau with big data. That's exciting. I know people here try them or preaching the choir, but that's one. You've got to think about some of the logic up front in these self-service use cases and kind of be planful. Our live connectors, those big data platforms, are valuable in the right situations, right? It's not a one-size-fits-all strategy. Same with the TDE. We work with the leading companies and leading technologies in this area to keep improving for you guys, both of us closely together, or us with all of those companies together. And there's a lot of flexibility in how you deploy. So no one-size-fits-all strategy, but a lot of options and a good roadmap that hopefully we've laid out a bit how to do it. So our session slide disappeared, or maybe it's after this, but we've been informed, please fill out these surveys. I always think back to the car dealership scenarios when you get these, right, where they say, unless you give us all 5s, we've failed, so please only fill this out if you give us perfect scores. We'd actually like to get real feedback, so you don't have to do that, but we have been told we have to walk home if we don't get perfect scores, which to London will be very challenging. Okay, that's it. There are some other great customer sessions that have been going on specifically around the big data space. So just search for big data or Hadoop in the app, and you'll see GoPro, Netflix, tons and tons of good ones. Great one from Barclays this morning.
If you've got any questions, come on up.
Yeah.